What's up? What's up? What's up? It's your boy, the network. And today's topic is section 3.19, configure and verify EIGRP neighbor relationship and authentication. This is part 2 of a 2-part series. We're doing the same topic as the last video, but we are now doing authentication. This is a topic in the CCNP route exam code 300-101 version 2.0. Let's take a look at the exam blueprint to see where we came from and where we are headed. Hashtag labeveryday. All right, this is the exam blueprint implementing Cisco IP routing, exam code 300-101. We just wrapped up the first part of this topic, 3.19, configure and verify neighbor relationship on authentication. We only did the neighbor configuring and verifying EIGRP neighbor relationship. We used Boston NetSim to basically configure and verify neighbor relationship with EIGRP routing protocol. Now we're going to do the authentication portion of EIGRP neighbor relationships. I didn't want to do it in the last video because it would have been too long, so this is why I did a separate video. After that, we are going to configure and verify EIGRP stubs. Again, we're doing authentication. So what is authentication? First of all, let's talk about EIGRP as a routing protocol, right? EIGRP is a routing protocol that we use for routers to share routes, right? They say hello to each other, and then these parameters have to match, and then they become neighbors, right? And then they can start sharing routes so that way they know different ways and the best ways to get around the network efficiently. What is authentication? First of all, let's say somebody's knocking at your door, right? Somebody's knocking at your door. Your first inclination is to do what? Say, who is it, right? Or who are you? Or who's there, right? Why do we do this? The reason why we do this is because we need to verify the person's identity before granting them access to our home or our office or whatever, right? That's our form of authenticating somebody's identity. Well, we do the same thing in the IT field, except we do it in forms of what? Usernames and passwords, right? Before I grant you access to this website or this account or this bank account or whatever, you got to give me a username and password. There's also retinal scanners. There's facial recognition. There's fingerprint readers. There's all kinds of ways to authenticate someone's identity. We do the same thing with EIGRP authentication. We are verifying another router, right? A neighbor or somebody who says they're an EIGRP neighbor. We verify their identity before granting them access to our routes that we're going to share with them. The reason why we want to do this is because let's say we have an office, right? And let's say we have a large corporate office and we have like I don't know, like a break room or even a cubicle in our regular offices with open jacks, and we haven't secured them because we have a junior network engineer that, you know, works that specific corporate office or whatever, or remote office. And since the jack is not secure, let's say somebody plugs in a laptop and they have GNS3 on it, or they plug in a router and they say they just pretend they have an EIGRP router, and they try to connect or try to be neighbors with another router that's in our network, and now they have access to all of our routes to our networks. If that person has nefarious intentions, they could bring down our network or do whatever, hack our network essentially. So let's go ahead and head over to the slides. Let's go ahead and head over to the next slide for the official definition. So EIGRP authentication: preventing a router from receiving fraudulent route updates by configuring neighbor router authentication. You can configure EIGRP neighbor authentication, also called neighbor router authentication or route authentication, such that routers can participate in routing based on predefined passwords. So it's just like granting access to your Gmail account, right? Before you have access to it, you got to do what? Put in your username and password, because I need to know who you are before I let you into this email account or this bank account or whatever the case may be. We do the same concept applies with EIGRP neighbors. Before I give you access to these routes, and before I let you, let you onto this network, you need to verify your identity before I become an EIGRP neighbor. So there's 2 types of authentication. There's simple password authentication, also called plain text. So basically, you send in a username and password with clear text, and it's not encrypted, it's not hashed or anything like that. It's not very secure because obviously if somebody has Wireshark, they could just read the username and password. So this is the reason why we want to hash the passwords with MD5. MD5 is supported by OSPF, RIP version 2, surprisingly. Y'all know how I feel about RIP, BGP, and EIGRP, right? Well, actually, I'll take that back. The routers that I have on GNS3, the images I have are version 12. I don't have any version 15 routers I really need to upgrade them. Find some images that are version 15. But anyways, version 12 only supports MD5 on EIGRP. That's the reason why we're using MD5. SHA-1 and SHA-2, those are more stronger hashing methods. But for this example, I'm going to be doing MD5. Remember, this is not encryption. This is a hashing method. These are the steps to configuring EIGRP MD5 authentication. First thing you want to do is create a key chain. You create the key chain, right? Which is a group of possible keys or passwords. Then you are assigning a key ID to each key. So you add the key. You got the key chain, right? Then you have to add the keys to your key chain. And each of these keys, you can give them to different routers, right? Or you just create different, you'll see, we'll create different lifetimes. This key could expire. You can't come in, you can't become a neighbor anymore. We'll be able to, experiment with all that. I'm not going to make this video too long. We'll try to keep it simple. Then you identify the key. You specify a duration of the key so you can make it. It's just like a, you know how sometimes these temporary passwords that you got, they send to your phone before you're granted access. The same concept. You could do, the same concept applies to this when you do a temporary key. You specify the duration of the key when it will be valid. This is optional. You don't have to do this. You can make it, last forever, just like a username and password. You can enable MD5 authentication on the interface, which you definitely want to do, so that way it's not in clear text and anybody can see the username and password. Then you specify the key chain on the interface it will use. So if you're connected to a specific device, you want to put that key chain on the interface that you're connected to that device. And these are the steps. Configuration. First, create the key chain. And then you give the key chain a name. Then you do a key ID. So basically the key. And then the password will be the key string. And then you create the password. That will be your key string. And then these are optional, obviously. These two right here are optional. I just realized these are both the same. But you could create one key and make it expire at a certain time or start and end at a certain time. You can get real creative with it. Don't know why you really want to do that. Let's say you have a temporary vendor that needs access to your network. That's a very common reason. Let's say they come into your network and they have some work to do or whatever, and they just need to be granted access, and you just happen to be running EIGRP. You can just give them a temporary key. It'll last for, like, say, they're only going to be there for 24 hours or 2 days, 48 hours. And then they can get granted access to your network for 48 hours. As soon as they leave your campus or your corporate network, it'll expire. They can't just jump back on your network whenever they feel like it. And then this is a way to configure MD. This says MD. It's supposed to say MD5 authentication. That way you are hashing your passwords. That way it's not in clear text. Remember, there's a difference between hashing and encryption. It's not encryption. MD5 is a form of hashing. I'll leave a link in the description below for more clear explanation of the difference between hashing and encryption. So let's go ahead and spin up GNS3 and do a hands-on lab of EIGRP authentication. All right, so we got a real simple topology right here. We got two routers here, right? They sitting in the, this is EIGRP process number 1 they are in. This is network 192.168.12.1/24 network. This is .1, this is .2. They're both connected to a local fast Ethernet interface. Console into the Orlando router. One is the Orlando router, one is the Miami router. We'll go ahead and console into the Orlando router. And this is the reason why do we need to do authentication with routers. Again, if somebody comes on your network, let's say, this is in Opa-locka, Miami. This might not be a very secure router, so we need to put these, or maybe it's in a really sketchy neighborhood of Miami. We want these routers to be secure, so that way nobody's just coming onto our network whenever they feel like it. We are going to go ahead and console in the Miami router as well. We got some tasks over here on the right-hand side. Verify routing tables on EIGRP neighbors on both routers. I meant to say also, Miami has these loopbacks right here. Orlando don't have any, and we need to see if Orlando has access to these networks right here on to the Miami networks. So let's go ahead and show IP routes, and he does. He has the connected route, the 12.0 network, which is this guy, and then he has EIGRP, right? This D right here, right? This D stands for EIGRP. So he has access to the 16.5.0 network, 16.6, and 16.7.0 network, 6 and 7 networks, right? AD is 90, and those are the metrics, right? Next thing it says here, so and also says here to verify the neighbors. We need to verify our neighbors. I'm pretty sure it's already set up. Show IP, EIGRP neighbors. And yes, we do have a neighbor, 192.168.12.2. That's this guy right here. That's the Miami router. So we are neighbors. On the Orlando router, create a keychain. A keychain first. We do the chain, and then we do the keys. On the Orlando router, create the keychain and call it bruh keys. Why did I name it that? I couldn't have been more creative than that. We go to global config mode, configure terminal, and the create the keychain is simple, keychain, and then you do the name. It's case sensitive. If these don't match, this may not work. Bruh keys, and now you're gonna, as you can see, we are in keychain configuration mode. There's all kind of sub configuration modes. You'll see now that we're in keychain configuration mode. It says here, give the key an ID of 1. You can put any key, but the key number got to match. So key, we're going to call it key 1. And notice now we're in keychain sub-configuration mode. So now give it a password of Cisco. This is also case sensitive. The password is a key string. It's kind of like SNMP. You know, you have community strings and stuff like that. That's what they call it. I don't know why they couldn't just call it password, but that's what they do with passwords, with SNMP and keychains and stuff. The key string, right? So it's Cisco, and that's the password. Right now it's clear text if we leave it as is. Next step is to verify the keychain that we created. So let's get out of this. We created our keychain and our key, right? We created our keychain and then we created our key. Let's go ahead and verify that. Show key chain. And there it is, right? The keychain is bruh keys. The key is key 1. We created the password of Cisco, but right now it's in clear text. There is no, we haven't set any lifetimes. They don't expire. So basically it's an infinite key. It's just like your username. Most of y'all, I'm pretty sure, have a username and password to your email that you didn't make expire, right? So you always have it that way. You can change it if you want to, but this specific key does not have an expiration date. Apply the keychain on the interface that's facing the Miami router. Okay, what's the interface? Right here, FA01 or FA00, Fast Ethernet 00. So we are going to go to global config mode, configure terminal, interface not GI 00, right? And now we're going to apply the keychain. Do you remember the commands for that? It was in the slides. Let's go ahead and check that out. This is how we configure authentication on the interface. You go to the interface config mode and then IP authentication keychain and then EIGRP, the autonomous system, and then the name of the chain. This right here enables MD5 on it, but I want to show y'all the difference of when you don't hash it. So IP authentication, right? What was the next? And this is why you don't have to memorize every single thing, right? Because you can question mark. I believe you can question mark on the exam too. I can't remember. Keychain, right? EIGRP. Now the autonomous system number. I don't remember what it was, so let's go ahead and do a show IP protocols. And the autonomous system number was 1, so it's EIGRP 1. Let's go back into that mode, config terminal. Go into back into the interface, FA00, IP authentication, keychain, EIGRP 1, and then the name of the keychain, which was what? Bruh keys, the keychain, right? Bruh keys. And that's it. So now we've created it, and notice EIGRP went down, but it also came back up, right? Because we essentially sent the password out. Why? Let's double check. Can we still see our routes? Do show IP routes. Yes, we can. We can still see our routes. Well, didn't we create a key in a keychain? Yes, but it's clear text. He can see it. Let's go back to Miami and see what happened. Goodbye has been received, so EIGRP went down. And we got a new adjacency. It came back up. Let's go to go back to Orlando and ensure that the keychain is not in clear text, right? How do we do that? MD5. That's how we hash our passwords. Again, MD5 authentication is supported by OSPF, RIP version 2, BGP, and EIGRP. We go IP authentication, mode, EIGRP. The AS number was 1. MD5 is the keyed message digest, MD5, and that's it. Now we've hashed our password, and now you can see EIGRP is down. Authentication mode changed. Let's go to Miami, see what happened. Authentication failure. So he don't know the password. We have to tell him what it is. So we need to go back to Miami and create the key chain, and then actually put it in. So now we're in Miami, and we're just going to do the same thing, perform the same tasks on the Miami router. Let's go to global config mode, configure terminal, key chain. Now we're in, my bad. We got to name the keychain, bruh, keys. And then the key ID is 1. Now we're in keychain mode. The password was Cisco. Remember, it's case sensitive. These got to match. I should show y'all what the difference. Let's go ahead and put it in lowercase and see what happens, right? And then also do MD5. So now we put Cisco as the password. My bad. We got to do key string and then Cisco. Now created that password. Next thing we want to do is verify that it was created. Do show key chain. And there it is, right? But we intentionally put the wrong password. There is no lifetime, so it always lasts. You know how sometimes some websites force your password to change after like 90 days? That's basically what you could do right here. That's the option. We may or may not, if we go too long, we'll do some lifetime tasks, which I've created here at the bottom. So now that we've created the key, let's go to the interface facing the route, facing Orlando, which is FA00, and place the key and the keychain on there. We're going to go to interface configuration mode, interface FA00, key, my bad, IP authentication, keychain, and it's EIGRP 1, the name of the keychain, keys. So we created a key, we put the keychain, placed the keychain on the interface, but it's not hashed yet, right? So let's go ahead and hash it. IP authentication, keychain, mode, EIGRP 1, MD5. Now it's hashed. It's not authenticating. Why not? Why not? Because we ain't got the right password. Let's go ahead and go back and fix the password and see what happens, right? I'm pretty sure we still can't see the routes, right? That's what I meant to show y'all, right? Since authentication mode changed and the password is hashed, can we see the route now? This is the routes on Miami router. Do show IP route. He only sees the connected route now. Remember, he was able to see it before. I'll show y'all. He was able to see those routes, the loopbacks on Miami router. Now he no longer sees them, right? So let's go back to Miami and fix the password. I can't even think right now. Key, chain, keys. And then the key ID was 1. The key string we said was Cisco, but we put it all lowercase intentionally. Let's go ahead and fix that. Do Cisco. Waiting. And now we got an adjacency. It's back up. Can Orlando see those routes now? As we can see, new adjacency. Do show. Let's get out of this. Show IP routes. And now we can see those loopbacks again. So I think we got time to do some lifetime tasks. So let's go ahead and do that. We're going to create, we're going to remove key 1. We're going to go to configure, global config mode, terminal, key chain, keys, no key 1. We're going to remove the key, right? And you'll see we got an authentication failure. It went down, right? We're going to go back to Miami and do the same thing, remove the key chain. Remove the key, not the key chain. We're keeping the key chain, but we're just going to change the key. It's the same concept. These were appropriate. These were appropriately named. This mode. No key 1, right? So now key 1 has been removed, but we still have hashing. We still can't see the routes, right? So do show IP routes. Right. So we're gonna we removed key 1. Let's verify that too. Do show key chain. I guess we removed our keychain too, didn't we? Do show key chain. Yeah, we removed the keychain altogether. So we need to recreate the keychain. I didn't know that. I didn't see that coming. Okay, so we're gonna try to perform these lifetime tasks. we're going to create some keys that's going to expire. First thing we need to do is, okay, so we removed key 1. We're going to create key 2 on the same keychain with the password of Trina. What, I picked that? 305 area code, you know, Miami. So let's go ahead and go to the keychain. So keychain, and then we're going to call it the same thing, bruh keys. Now we're in keychain configuration mode. We're going to create key ID 2. And we're going to configure the keychain lifetime. Here's the options. I'm going to show you. We got accept lifetime to set the accept lifetime of the key, and to send lifetime to set the send lifetime of the key. So we're going to do, let's do send lifetime. So we're going to do send lifetime. The time to start right now is 10:01 in the morning. Let's do 10:04. Okay, notice it says here, make it valid from today until 3 minutes later from the moment you configured it. So we're going to have it start at 10:0. Actually, let's do, 10:04. So that way it gives me enough time to go to the other side. And the date is April 15, 2019. You got to get your taxes done today if you haven't done them yet. The duration is, we could do either the time that stops or put infinite, that it never expires, and set the key lifetime duration. So we're going to set the key lifetime duration. It says seconds here. We can only do seconds. So it says 3 minutes. So we're going to do 180 seconds. We're going to take this same, so that way we ain't got to type all of this, and put it in the Miami router. Key chain. Now we're in keychain configuration mode. Bruh keys. Key ID is 2. Oh, we forgot the key string. That's what we forgot too. Key string is Trina. All right, so key string Trina, and then we're going to put that send lifetime 180 seconds. Let's give it a little bit of time. Let's see what time it is on here, because we're not going by the computer time. Show clock. Do show clock. Right now it's 10:02, so it should start at 10:04. This keychain. We'll wait. I'll probably fast forward, that way you ain't gotta sit through this. We got an adjacency. We got an authentication failure on Orlando router. Waiting. Let's do a show clock on Orlando. It's 10:03. Remember, we set it for 10:04, right? It's 24 seconds, 33 seconds. And why would you want to do this? Let's say you have somebody, like say you got a vendor coming into your office, right? And they need temporary access to your network. Obviously you don't want to give them access. Let's say they need access for like 24 hours or something like that, or 48 hours for them to do some work on your network. And they have a router and they need to for some reason, create a neighbor relationship between EIGRP with the routers. So you do that, you hand them this, you give them this key, and then you can see now we have a new adjacency. It came up. Now they only have, in this case, they only have 180 seconds or 3 minutes to do whatever they need to do to get on our network and get off our network right afterwards. So now we have a new adjacency. Let's go ahead and check our routes again. And the routes are back. Let's give it a little time to expire. And there we go. 3 minutes later, interface goodbye has been received. And on Miami, we got an authentication failure. Can we see the routes now? Do show IP route. And now they no longer see the routes on Miami. So that's all I got for y'all today. If you like this video, that's my contact information. That's my YouTube. Go ahead and please like, subscribe. That's my Twitter contact. That's my Twitter handle right there, @networkbruh. Go ahead and add me on there or share this video. Please comment, like, subscribe to the network.